Hi, hello everyone. Me Gopi Nalla, graduated from IIT Kharagpur. Today I am going to discuss about the another method of the cavity problem. By using this method, we are going to find out the moment of inertia of remaining portion of an object. Let us see the concept. Let us consider the uniform disk. The mass of the uniform disk is capital M. The density of the disk is sigma kg per meter square. The uniform disk is the two-dimensional object. That is why we need to give the density sigma is equal to mass by area. Now we are removing some part from the disk. The radius of the removed part is r by 4. The mass of the removed part is small m. So this one you can write r dash is equal to r by 4. From center to this distance, you can give d, so that the d is equal to, you can write r minus r by 4. What is the value? 3r by 4. Now we need to find out capital M value and small m value. So consider the density sigma. Sigma is equal to, first case, the mass of the whole disk, that is m by pi into r square. From this, what about the capital M value? Capital M is equal to sigma pi r square. Again, we need to find out small m value. Sigma is equal to small m by pi into, what about the r dash value? R by 4. So r by 4 whole square. From this, small m is equal to sigma pi r square by 16. Now we need to find out the net moment of inertia when the material removed from the uniform disk. So that I net is equal to I1 plus I2. I1 is the moment of inertia of the whole disk. I2 is the moment of inertia of the removed portion. So what is the moment of inertia of the disk? mr square by 2 plus, what about the moment of inertia of the removed portion? As per parallel axis theorem, I2 is equal to, you can write ICM plus m into d square. So the moment of inertia of an arbitrary axis is equal to the moment of inertia about parallel axis passing through the center of mass plus the product of the mass and the square of the distance between the two parallel axes. So m, what is the m value? Sigma pi r square. Sigma pi r square into r square by 2 plus, what is the ICM value? That is m small m into r dash whole square by 2 plus m into, what about the d value? 3r by 4 whole square. Now you have to put the remaining values here, is equal to sigma pi r power 4 by 2 plus small m value sigma pi r square by 16 into, what about the r dash value? R by 4 whole square into 1 by 2 plus small m value again sigma pi r square by 16 into what about 3r by 4 whole square, that is 9r square by 16. Now here we are removing some part, that is why we have to put the negative sign for that mass. That is why this value is negative, same time this value is also negative. So you have to put the negative sign here, minus, and again you have to put the negative sign here. Now simplify this equation. I net is equal to sigma pi r power 4 by 2 minus sigma pi r power 4 by 16 into 2. So 508 minus sigma pi r power 4, 9 is there, 9 sigma pi r power 4 by 16 into 16, 256. Now again we need to take the LCM. So I net is equal to, the LCM is 508, so 256 sigma pi r power 4 minus sigma pi r power 4 minus 256 into 2, 2 into 9, 18. 18 sigma pi r power 4 is equal to 256 minus 90, 237 by 508 sigma pi r power 4. If you are simplifying this one, then I net is equal to this value 0.466 sigma pi r power 4. This one you can change into the capital M value and the same time small m value also. So the final answer is I net is equal to 0.466 sigma pi r square, that is the capital M. So you can write this one is m into r square. So likewise we are going to find out the moment of inertia of remaining portion of an object. We have many problems, we need to discuss those problems also. Have you understood, children? Thank you everyone. Let us see the another problem based on moment of inertia of remaining portion of an object. Very first, consider the again uniform disk with radius 4r. Now we are going to remove some part from the uniform disk with radius r. From this point to this point, the distance is 2r. The mass of the whole disk is capital M. The mass of the removed portion is small m. The density of the disk is sigma kg per meter square. Now we need to find out the moment of inertia of remaining portion of an object. Let us see how we are going to find out. Very first, take the density. Sigma is equal to, first case, capital M by pi into, what about the radius of the whole disk? 4r. So 4r whole square. From this, M is equal to 16 sigma pi r square. Now again you need to find out small m value. So sigma is equal to small m by pi into, what about the radius of the removed portion? R. So pi r square. From this, small m is equal to sigma pi r square. Now we need to find out net moment of inertia. So I net is equal to I1 plus I2. I1 is the moment of inertia of the whole disk. I2 is the moment of inertia of the removed portion. So you need to find out I1 and I2. So I1 is equal to, what is the moment of inertia of the disk? Mr square by 2 mr square by 2 plus, how can we find out the I2 value? In the sense, as per parallel axis theorem, the moment of inertia of an arbitrary axis is equal to the moment of inertia about parallel axis passing through the center of mass plus the product of the mass and square of the distance between the two parallel axes. So that I2 become ICM plus m into d square. So now substitute the values here. M into, in the place of r we have the 4r, so that you can write 4r whole square by 2 plus, what about the ICM? Small m into r square by 2 plus m into, what about the d value? The d value is the 2r. So d is equal to 2r. That value you can substitute here, 2r whole square. Then how much you are getting? Substitute the capital M value and small m value. Capital M 16 sigma pi r square into 16 r square by 2 plus small m value sigma pi r square into r square by 2 plus, why? Because here r, both are same, that is why I have taken same value. Again small m sigma pi r square into 2r whole square, that is 4r square. Here we are removing some part from the uniform disk, that is why we need to give the negative sign here on. So that is why here you need to put negative sign, here also you need to put negative sign. So then how much you can get? I net is equal to, so 2128, so 16 into 8 128 sigma pi r power 4 minus sigma pi r power 4 by 2 minus 4 sigma pi r power 4. So 128 minus 4, 124. This value is the 0.5. So that how much you are getting? I net is equal to 123.5 sigma pi r power 4. So likewise, we are going to find out the moment of inertia of remaining portion of an object. The method is same. So every time you need to apply the same method. Clear? Have you understood this one? Thank you everyone.